questions in similar exams?
Yeah, because he's lazy. Like,
Yeah.
professors don't want to write
probably.
new shit. They don't want to write new stuff.
Which, I mean, some of these variational problems are pretty tough. These Lagrangian questions where I have to, I don't know, set up the whole Lagrangian of this, and I have a ball on another ball, and then I have translation kinetic energy and rotational kinetic energy, and then I have to calculate the force of constraint, and then in x and z direction, but then I need in r direction and phi direction, and then
Yeah,
God.
it's a mess. It's a mess, dog. I feel you, dude. Okay, video ID. Here, I'll just add the video ID. There we go. Let's see if it adds. Did you have a lecture stream today, Shantrix asks? No, I did not. My last lecture at UCLA was on Thursday. And then Friday, I gave them the final exam. And then, what was it? This weekend, I've been grading it. Let's see. Is that working? Cool. Awesome. All right. Sweet. All right. Let's kick things off and go help Zorn out with some really hard physics. All right. Welcome everyone, office hours. My name is Dr. Phil, Sex Education. Stream that helps you with math homework, science homework, all sorts of fun stuff. What's up, Sib? Oh, Sib's in the chat. How's it going? Yeah, no. I didn't have a lecture on Friday, Shantrix, and I didn't have a lecture this morning. I was just grading. Just been a pain. Grading sucks. Let's see. Where was your thing? This was it. Okay. So,
that's
number 1,
no,
part B.
the-
Is that what you're saying?
That's the. Wait a minute. I think that's the wrong one because I think that one I can do. It's from the last thing I sent you, which is sadly in German.
Oh,
this
Deutsche?
Sprechen Sie Deutsch?
Was ist los?
Was ist das? Okay, it's this one,
Yeah,
but what?
sensation.
Part B? Is this what it is? Is part B?
Wait. It's. Well, I'm a bit
Diese
confused right now
Aufgabe
because
geest is on alle minjes. What the fuck is that word?
Can you maybe open up our chat on Discord?
I
Because
can.
it's supposed to be a Klausur 17.
I don't know what these words mean. But okay. Here's our chat.
The one with the number 17.
Oh, this one.
17 and 117 LSG. LSG stands for solution.
Okay.
X solution. No.
Let's grab that. Okay, let me close these things.
Make sure to open the first 17 one, because the other one is just the solutions, not the actual question.
I feel you do. Okay, here we go. So this is the solutions, and then this is the question, right? Formal Sammlung. Formulations, I guess. Yeah.
Formula collection.
Yeah.
Yes,
oh, thanks, Sib.
I
appreciate that, Sib. Thank you so much. Sib says, thank you for being such a great teacher, Dr. G. You have no idea how much it means to me. Oh, I love hearing that, Sib. Thank you so much. And please, yeah, always come by the streams here, even after this class is done, which, I mean, yeah, I'm sure you have future physics classes you have to teach. So please feel free to come by the streams and we'll help you out. Like we're doing here, helping out Zorn, a student from Germany who has an exam in a couple hours, or 16 hours, I guess, about what looks like kind of advanced, like Lagrangian and Hamiltonian physics.
Okay, so
which one?
The C. Is it C? C1.
Do I need to? Sorry, one second. Do I need to know part B and A in order to do this one?
No. Part A and B are independent.
Okay, here we go. All right, so we're gonna do this. I have no fucking clue what this is, but okay, cool. Okay, And actually, yeah, what I'm gonna do is I'm gonna ask ChatGPT to translate this for me because I don't speak German.
What? Is that not a requirement for physics in America?
You know,
German?
in math, apparently, even in America, if you're learning like high level math, you have to learn French because some like math papers, the French are very French. They're so like fucking particular. But some of these math papers that got written, the mathematicians that wrote it put on like their deathbed as a requirement that it can never be translated into another language besides French. That like it's forbidden for anyone else to translate their work into another language outside of French. And so math students have to learn French in order to read some of these papers. Pretty dumb. Yeah, it's very French. Okay, here we go. We got the English.
Someone
We
needs
got
to
the,
remind the French that they lost the war 3 times. So
yeah. Yeah, somebody needs to remind them they're
you lost the 100 Years' War. You lost the Napoleonic Wars. You lost the 7 Years' War. Shut up already.
You lost World War I. You lost World War II. Okay, consider this. Where alpha, KL, and so V's a potential usually, right?
Yeah.
I know that. This is, I want to say, kinetic energy, but in the fuck? Why is there a K and an L? Are there 2 particles? No.
I have no idea.
Okay. Well, that's okay. I mean, I see this, right? This to me is the Lagrangian for the position of a particle K, the velocity of a particle K at some time t is usually equal to, yes, Lagrangian is this minus potential. Hamiltonian is like plus potential, I think, usually, right? It's like H plus V.
Yeah.
And then this is 1/2. I want to say this is like M, and then this looks to me like V squared. Except that
actually is M. Well, the alpha KL, I remember my tutor told me it stands for any mass.
Any mass, yeah.
Like,
okay, so
that's important for part 3I, where you have to look at what is conserved. But yeah.
Got you. Okay. I'm just confused why the fuck there's another indice with L.
Yes, that's also my problem, because in part I, calculate the associated conserved quantity Q. You have to use the formula in the formula collection.
Okay, in the formula collection, which one is it? Is it Noether's theorem?
So the Q is something. So
here, we're just gonna take all this. We're just.
I can. Yeah.
This.
I can tell you. You only need the first part, which is summation partial L partial Q dot. Yes, that's the only part you need for this.
Okay.
For this whole number 1.
Yeah, dude. Like, what is this? Like F? What is this, dude? What?
Well, the F is if you take the derivative of epsilon. No, if you take the derivative of L with respect to epsilon, you get the time derivative of F. But that's it's the expanded Noether theorem. That's number 2. No need.
So okay, this is all like Noether's theorem is what it is. Maybe here, let me.
Yeah.
Can I like refresh like what the fuck Noether's theorem is? Like here, I'm gonna go to ChatGPT, just have it explain it to me. Nasser says, how are the homework and pre-lecture grades determined? It's just points. I think pre-lectures were a maximum of 5, and then homework was whatever, how many questions there were. Okay, we're gonna use advanced reasoning. I'm gonna be like, explain to me what Noether's theorem means for physics. Is this mechanics specifically, or what are we in?
Classical mechanics.
Yeah, for classical mechanics. Okay, whatever. Let's just have it explain it to me, please. Connects symmetries and conservation laws. Time invariance leads to energy conservation. Okay. Every continuous differential symmetry of the action corresponds to a conserved quantity. If a system's action, if it's Lagrangian, looks the same after you nudge it in some smooth way that depends on a parameter, then something you can calculate from L never changes in time. Okay, that's cool. Kind of makes sense. So action is integrating the Lagrangian from two different time points. Hamilton's principle says that the actual path makes delta S equal to 0. Okay, so so it's invariant of the path. It doesn't matter like what the path is. Okay. A continuous symmetry is one parameter transformation such that Qi going to Qi prime is the same as am I late, bro? You're fine, HH. Qi plus epsilon delta Qi plus order epsilon squared. Okay, cool. That leaves S and hence LDT invariant to first order in the okay. dj dt is equal to 0. J is constant. My class did end, HH. Yeah, it ended on Friday. The final, it was not bombed. I think the median was 84, so that's not bombing a final. That's pretty decent. Okay. Plug the symmetric variation, integrate by parts, use Euler-Lagrange equations to show that the total time derivative Okay, let's say for a free particle in one dimension. Okay, L is 1/2 m x prime squared. Is invariant under x goes to some new position x plus some like wiggle epsilon. So if you do dl dx prime, you get m. Okay, cool. I see that. You get m x prime, and then y is delta x just equal to 1. Do you see that? Why is delta x equal to 1? I'm gonna ask it. Okay, we'll get to that in a second. So P dot is equal to 0. Okay, sure. And MV is conserved. Okay, y physicist cared. All right, cool. Okay. Let me say, for the micro example of free particle in 1D, y is delta x equal to 1. What's up, Femvox? I'm doing some Noether's theorem, some high-end stuff. Correct, Nasser, that is correct. Yeah, it's not, each homework is not weighted equally. It's by the number of questions you had to do. Okay, let me see.
That just means that psi is whatever the factor of epsilon is.
Okay. Yeah, no, I get this. I get like this order epsilon squared, whatever. You get rid of these terms. But if x goes to x prime, which is equal to x plus some epsilon, comparing this with the generic form. Oh, okay. Delta x equal to 1. It doesn't say the particle moves meter. It says, when I vary x by a small translation epsilon, every point gets shifted by the same amount, independent of x or t. The generator of the symmetry, bro, this is where I'm like, I'll stop. It's starting to give like some ridiculous stuff here. Okay. Like, why can't delta x just be like 2? Okay. Sure.
Delta x.
I get it. It's because every point gets shifted by the same amount, and it's independent of x or t. Okay. I think I see. I think I see. I understand why that's equal to 1. Yeah. Okay. Okay. So then let's go back to this question. Now that I kind of understand how Noether's theorem works. Right. Okay. Cool. For k is greater than or equal to 2, t prime is equal to t.
Well, what that means is we have in the formula, there's the psi I. And that means if psi I is 1, or I think, no, if psi k is 1,
psi k.
then the thing that looks like Poseidon's scepter, if the indice is 1, then psi is 1. if the indice k is 2 or 3, then psi becomes 0.
Oh, okay. Okay. So it's just in one dimension, I guess. That's what we're saying, right? Like the transformation's is in only one coordinate axis. Is that what we're saying?
Yeah, well, it means that only.
Oh, I see. I see.
Q1
QK equals QK
transformed.
prime. Yeah. I see. So if K is 2 or greater, right, then you don't have any transformation, right? From Q1 to Q1
Yes.
prime. Got you. Okay, cool.
Yes.
Okay. So calculate the observed quantity that's conserved. So I just need to do dLdt of this thing, I think, right?
Partial L, partial Q dot.
Sure.
Of that thing.
Good. Okay, fine. All right. So let's try to do that, right? So I'm gonna say partial L, partial Q dot. And let's do it in the first indice first, I guess, right?
Yeah.
And then L is equal to this huge mess, right? Alpha K equals alpha. Oh, okay. So that derivative, right? K and L equal 1. So here's the interesting thing. Wait. Do K and L equal the same thing here? Or Zorn, does it iterate? Like it's K is 1, then L is like 1, 2, 3, 4, and then K is 2, then L is 1, 2, 3, 4.
Sadly, K and L are not the same. That's what I asked ChatGPT.
Damn.
That sucked.
That sucks. Okay.
Yeah.
Okay. Well, the only thing that's going to survive here, right, is if this is equal to like whatever this thing is, right? Otherwise, it's a constant. Yeah. So, and then do we have to do things with V? Like, do we have to? I hope V is equal. V does not. Oh, V does depend on the coordinates, but it doesn't depend on Q dot, right? Okay. So what that means is, right, is that when I take this derivative with Q dot, this goes away.
Yes.
Okay, cool. All right, we're getting a little bit closer.
I mean, if you want, you can take a quick look at the solution because
I'm gonna take a little bit of look at the solutions now because now I'm starting to get it. Okay. All right.
That's A.
That's the answer.
Down.
Or sorry. I was like, where the fuck did MR dot come in from here?
Wait. No, I think that's the wrong exam you opened.
No, this is SS17, right? It's the same thing, no? Yeah? I think I picked the right thing. Oh, yeah, no. SS17, and I'm looking for... part C. I'm looking for part C. Sorry, that's what I'm looking for. Sorry.
Yes.
Yeah, where the fuck is this? C. Oh, this shit. Okay.
Right there.
Temp says, "Hi, Dr. G. I'm also taking Physics 1C right after your 1B class. Is it alright if I come to office hours?" 100%. You are more than welcome to come by these streams to ask for help. Yeah. Okay, so wait. Let's pull this solution in. This is just for part 1, right? Wait. This is all... This is... Wait. Sorry.
Well, no. Well, C in itself has...
C has 3 parts. Oh, my God.
I, and I.
Dude.
And the first
God damn it.
is part I.
Got you. I see it right here. Wait, what happened to part 2? Why does it skip all the way to part 3? Where's part 2?
Part 2 is direct beneath where it says mx.1. That's the solution to part 2. I really only need the solution for part I because then the other solutions I get it.
Okay.
Because my first instinct was that K and L are the same, and then I would have had Q dot squared, and then but that's wrong apparently. But yeah.
Let's see. Okay. Well, okay. So let's think about this. When you take this derivative, right? So this right here is going to be the same thing as like 1/2. Let's say like alpha 1, 1, and then it would be Q dot 1, Q dot 1 plus like 1/2 alpha 1, 2. Then it's going to be like Q dot 1, Q dot 2, right? And so forth. Do you see how like we're just going to iterate through all these?
Yes.
When I take the derivative with respect to Q1 dot, the only thing that's going to survive is things that have q1 dot in it. So for instance, if I keep going with terms, and let's say I have 1/2 alpha like 2, 3, right? Q dot 2, Q dot 3. This is going to go away because none of this is Q1 dot. Yeah, so the only thing that survives is when either L is equal to 1, and then when you take the derivative, right? If this is like Q dot 1, this just goes away as, you know, what's it? So partial Q dot 1 of like Q dot 1, that's just equal to 1, right?
Yes.
So this term that survived here was doing partial Q dot 1 of 1/2 all the values of k, but L is equal to 1. And so that's alpha k, and then this was L, but that's equal to 1 now. Do you see that?
Okay, so in the first term, L is 1, that's fixed.
Good. L is 1, that's fixed, and that's why and that's why you're always gonna pick out these like QK dot terms, yeah?
Because only one is
only
okay.
only one survives, yeah, good. And then this case is only k equals 1 surviving. Yeah?
Okay, I think I get it now, yeah.
Good. Yeah, so I don't know. How does this add? This equals the sum of k alpha k 1 wait, what?
The factor 1/2 goes away, but apparently they just chose.
Oh, they renormalize. They just renormalize their indices. That's all they're doing.
And how does that work?
So they're like fuck this, dude. If it's L, let me just call it K. Like the letter doesn't matter. Yeah. So then you have the same summation twice. And I think the other key thing here, Zorn, is they say that alpha KL is equal to alpha LK. So you're allowed to do that. Yeah. So yeah, they just reindex this to K, which is the same as this, and you say, oh, the K's are the same. So now you get that.
But couldn't I then just from the beginning have just said, okay, instead of KL, I'm just going to call it KK? And then
no, because you would only get the diagonal terms then. You want to show that you're picking out, right?
Yeah, okay.
And then because it's symmetric, you have like two triangles making a fucking square. Yeah.
Okay.
Yeah. Well, that's like complicated. Okay, but wait, is that even like the answer? What did we even find out right now?
Well, you just calculated the conserved quantity Q.
Oh, did I?
That's,
oh, cool. Oh, okay, yeah, because that's Q. Yeah.
Well, I mean, here's the funny thing, because now that if we have AK1 and Q dot K, we can quickly do II and III. I promise I go quickly, because if you look at II, II, what does II say?
I gotta go like decipher it again. Sorry, this was
I can tell you even
these two. Oh wait, did I already get this? Did I already get this in the physics?
Yeah.
Oh, I did. Okay. Consider the case of a point mass with m and qk is equal to xk. For n equals 3 and alpha is m delta kl. Oh god, what? Okay, for n equals 3, potential goes away, right?
We have alpha k1 in A. That means alpha k1 becomes m delta k1.
Okay.
And that means the only thing that can survive is x1, because if k is anything other than 1,
right, it dies.
It becomes
okay.
0. So we have mx1, no, mx dot 1. And you can look at the solution, I'm right, because I'm the goat.
You are the goat.
Good job!
Okay, cool. Yes. I see. That's the only thing that survives. Okay.
And then, but part I kind of confused me, because don't look at the solution right now, because it's
I'm not gonna look at it. Let me look at the translation.
Look at the translation, yes.
Yeah. Who submitted this problem? HH Zorn did. Nasser, one sec. I'll get to you. I'll get to your questions about that. Okay. Now consider the case. Q1 is phi, Q2 is r. Okay, so now we're coming up with a different coordinate system, right? Give alpha KL without derivation and Q. What is the physical meaning of Q now? Oh, okay. So
Q1 becomes phi, I guess, which means that since QK, since X1.
Yeah.
Wait a minute. I'm ordering my thoughts. So X1 means Q1. So I guess we
just have it's symmetry around phi then, no?
Yes. So we have, I guess, M. No, wait. Yes. M phi dot 1.
And M phi dot 1 is, I don't know, is that like rotational inertia or something?
Actually, it is, yeah. But
it is?
I don't know how they got it. Because in the question, they... Like,
no. So alpha 1 1, right? Remember that alpha is so alpha KL is M delta KL, right? And then
that's what I said in the beginning there, that apparently alpha is just any mass for, and since we have phi dot, that means that mass has to be mr squared.
Wait. Why is the first coordinate r now? Wait, I thought we said the first coordinate was theta, was phi. Yeah, first coordinate's phi. So how are they getting mr squared here?
Maybe ask ChatGPT, because I really don't know.
Yeah, okay. I mean, I understand that mr squared phi is whatever, angular momentum, but but I'm curious where they're getting that from. Femvox says, "Is this relativity?" No, this is mechanics, but like on steroids. This is it's like graduate level
German
mechanics. Yeah, German mechanics. It's like Porsche and BMW. Okay. What in the holy hell are they trying to figure out? It's cool. It's a way of mathematically showing that you have conservation stuff in physics, like conservation of energy, conservation of momentum. All this stuff you can you learn it in undergrad as just like, this shit is conserved, and you're like, cool. Then when you get to higher level math, physics things, you start to show with numbers why that's true instead of just assuming it. Like there's underlying code that extracts this. That's where this comes from. Here we go. Explain this solution for part 3. Let's just see. It looks cool. It is. Yeah. There's an added struggle of we're doing with the language barrier as well. But yeah, this is mechanics, classical mechanics. That's what we say. Okay.
Oh, I guess.
For a particle in cylindrical coordinates, the kinetic energy term is this. Yeah, bro. Right?
Yes.
Yes. Okay. Since in the problem they choose the ordering of that, we can read off the metric coefficients as alpha KL, Q dot K, Q dot L as the diagonal matrix. Whoa. 1, 1. Wait. Okay, wait. Why is 1... Oh, wait. This is T, right? Oh. Okay. So if you're taking the derivative of the kinetic energy, Zorn, with respect to phi dot, do you see how this middle term, this r squared, is the only thing that survives?
Wait, I'm taking the derivative with...
Right, so...
With respect to phi dot.
With respect to phi dot, so...
So I get mr squared phi dot.
Yeah, so it's this, right? So you're going through... So instead of your Lagrangian being this, per se, I think this is... Because Lagrangian... L is equal to, what, T minus V, I think, right? So
yes.
This is now summation alpha, this is KL, whatever, Q dot K, Q dot L, right? But there's only 3 coordinates, right? There's Q1, Q2, Q3, okay?
Yes.
And then in your... So if you do DL dQ1 dot, for instance, right? Which would be the same thing as DL d phi dot, right? Of
Yeah.
L, but L is now equal to this thing, right? Do you see how the phi dot term that survives is just this?
Yeah.
So that's what gets you 1/2 m, and then it's d phi dot of r squared phi dot squared, right?
Yes.
And then the derivative of that pulls down the 2, and so you get just mr
Yeah.
squared phi dot. Yeah, right? Yeah.
Yes. That's the
Oh, okay.
solution.
Oh, is that what it is? Okay.
Yeah. It's if you look at the solution, it's m
Yes.
r squared phi dot.
mr squared phi dot, right? Yeah, okay. And that's yeah, okay. I don't know what the fuck they're talking about here. This is weird up here. I don't know this A11, A22, A33.
Yeah.
But I do understand that. I think from the you had to know what the definition of kinetic energy is in cylindrical coordinates, which is this. So this is kind of the key thing you need. Yeah. Interesting. I don't know where this comes from, this diagonal matrix. Write down the Noether charge. This is all like too much, dude. What? Yeah. All K1 vanish except for K equals 1. So you just get mr squared phi dot. And then, yes, cool. Which is angular momentum.
So when did you do stuff like that in your...
I did this in grad school. So I was probably 22, 21 years old.
Well, I am 22 right now, but I started
Then that makes
late,
sense. Yeah, no, you're okay. Yeah, this was like my first year of grad school at UCLA.
But I'm in my second semester of my bachelor.
Yeah, well, yeah, your physics is pretty extreme. This is like PhD track physics for me. I think I might have done it my like third year of my bachelor's. I might have like dipped into it a little bit, but I honestly don't remember much of my undergrad. But grad school, I do definitely remember doing Noether stuff. Yeah. HHH says, "What math is this?" This is classical dynamics. If you want to like, yeah, if you want to like see what this is like graduate level, it's upper division mechanics physics. That's what we say, upper division. Lagrangians and Hamiltonians. Yeah, if you really want to learn what this is Lagrangian and Hamiltonian mechanics. I'm trying to think like a good book on it. I wonder if there is actually a book on it that's open and easy. Oh, you know who made one actually? Sorry, I know who did one. University of Texas Mechanics. Oh man, Fitzgerald, I think is his name, or Fitzpatrick. Yes, this is he. Where is his? He made a. Here we go. There you go. Okay, there's a PDF of it online. Here we go. Okay. This is where's the stuff with like. No, where's his more advanced one? Let's see. Here we go. Because I took this class with this professor when I was a wee lad back in like 2009. I think this is it. Yes, here we go. This is it. So if you want to learn about this, this gets brought up into, Lagrangian dynamics, which is this stuff. This is what we're working through. This is kind of the intro into it. And then what Zorn's working with is probably the next level of it, because I don't think they do Noether's theorem here.
I'm in my second semester of my physics, and it's a pretty prestigious school I'm at in Germany. Like, it's
where you
also
at?
known
Max Planck Institute or Garching? Where you at?
No, that's an institute. I'm at Karlsruhe Institute of Technology.
Oh.
They got that name from MIT, by the way.
Oh, did they? That's
Yeah.
funny. Yeah. Euler's equations. Yeah, all this stuff. This is what all this stuff is. I can't believe someone wrote a book on this. But anyways, yeah. Here, I'll post this in the chat. If people want to go learn this at some point, this is what it is. It's Lagrangian dynamics, basically. Enjoy. Have fun with it. there's a link to it. What's up, AFG? Okay. What else did you need help with, Zorn? Was this kind of, this was a big part of it. What else was it? And then I'll answer some of the chat questions in the YouTube one sec after this. But
I think that's it.
Oh, that's
so
it.
far,
Okay.
I think, because I don't want to keep you up. The rest I can maybe understand. Also, I think I do understand it.
Okay.
I've memorized how to solve some problems, not the actual answers, but I've memorized how to solve some of them.
Yeah, as long as you know the process and how to do things, you'll be okay. And believe me, I've been in your position before. It was my first math class in college. I took vector calculus, like, out of the blue. And we started doing like Green's theorem and Stokes' theorem, and I had no fucking clue what was going on. But the days before the final exam, I just went through like previous exams, homeworks, and just kept doing the questions. And eventually what happened is your hand develops like muscle memory on like what to write down when it sees certain things. And so when I went into the final, again, I didn't really understand Green's theorem, Stokes' theorem. I still don't understand them. But when I saw those questions on the final, my like subconscious brain kicked in and it was like, oh, I remember doing something similar to this. Just fucking write some shit down. I ended up getting an A in the class. So it works.
Well, if maybe there's not a lot of requests, maybe we could quickly look at number 2. And for number 2, I think you can open up the exam in English that I sent you.
Okay.
If,
yeah, no, we can. I don't have a ton of requests so far. I'll go through the chats here. Tell me which one am I looking at? Which PDF?
The first one, problem set pre-exam.
This one?
Yes.
Okay. And then we're looking at what, problem 2 or
number 2? Yes.
Okay. All right. Let me pull that in. Galilean transformations, and then let me one sec go through all the YouTube chat stuff I had because I know some of my students from my UCLA class are asking questions. Let's get an age check on Zorn, bro. He's 22. He said he was 22. That's how old he said. Yeah.
Why are people concerned with my age?
No, they just think you're really advanced. They think you must be older than you are if you're like doing really high advanced stuff like this. But
It's
like
just
we
German
explained,
stuff, man.
it's just German stuff, man. Dude. It's just difficult. Yeah. HH says I haven't even learned anything about Lagrange yet. I take Calc 3 next semester. That's totally cool. Yeah. Lagrangian stuff is not until a couple years into your physics degree. Sorry, let me go through some of the YouTube chat because I know we had some questions from people. So, yes, okay. HHH, yes, we can go through your circuit stuff later today. I know you had like current sources in there, which was like a pain to deal with. Okay. Mistral said, when is the approximate time you think you'll get midterm 2 regrade requests done? Probably in the next couple days. I've been working like kind of nonstop trying to. This summer class, I'm gonna make a couple complaints about this summer class. It's way too fast. Like 6 weeks to do 10 weeks of physics is insane. And then from the logistical point of view, having to get everything graded and everything like put into Canvas, and I'm sure some of you guys saw on the notifications that you're getting stuff at like 4 o'clock in the morning. Yeah, because that's how late I was up transferring things over. It's an insane amount of work. And that's even with AI like helping me to convert, CSV files between different formats. Like if I didn't have AI, I'd fucking murder myself. Because it's absolutely nuts how much like you have to like manipulate things to get things to work. So yes, it was very fast paced. So that being said, I at least wanted to make sure that you got all your grades in. So you have all your grades on Canvas. Those should be pretty much finalized. And then you have your final exam grade. So you can go through and try to get more. I gave a ton of partial credit on the final exam, by the way. So like, don't feel super obligated that you have to like get more points. Like if you're already sitting at like an A or whatnot and you're fine, you already have a lot of partial credit. You don't need to submit a request. It's okay. Like there's no difference on your transcript between GPA-wise between like an A+ and an A. It's the same. So that being said, I did get everyone's exam 2 regrade requests in last night. That was the deadline. I will process them probably starting tomorrow. I need a fucking break. So probably tomorrow or the day after it, I'll start doing the regrade requests for exam 2. And then your final exam regrade requests are due by Thursday night because then I got to get through those and get final grades to the registrar by Sunday. So Thursday, turn those in. I'll get finals regraded like Friday or Saturday, and then Sunday it's like, speak now or forever hold your peace, because that's when like final grades get posted to UCLA, and then I can't change things after that. Not without like a lot of paperwork, which is really like annoying. Cool. Okay. Medical request for homework extension, that's fine. You could Nasser, that's fine. Just email me about the pre-lecture. I'll give you credit for it. It's fine. Yes, you're so good, Sib. Yeah. Yeah, just send those now that you have the solutions. And yeah. Oh, thanks, Sam, for the sub. Did our notification go off? Maybe it didn't. I don't know. Something's up with Sammy these days. Yeah, okay. I appreciate that. And you too, Sensation. I appreciate you also subscribing here. Awesome. Okay, cool. All right. Yeah, so back in the day, did you read books to find solutions to problems? Yes. Yes, we did, HH. Yeah. Or the big one was like Stack Exchange, or like Quora, or Chegg, right? Chegg had a lot of stuff. But once you started getting to like higher level, like graduate level physics courses, you were just screwed. Like, because there's not much in terms of help. Like, the amount of resources for help starts to decrease dramatically as you get to like higher level classes. Yeah. Chegg down bad right now. Yeah, I should probably cancel my subscription, honestly. I've paid for a Chegg subscription for probably the last like 5 years, 6 years. Just because it was always that was my like way of helping students out. If I couldn't understand something, I'd go check Chegg. I'd learn it in like 2 minutes, and then I'd go reteach it. I'd be like, all right, cool, got it. There you go. But yeah, now it's pretty much useless because ChatGPT is pretty fucking good at figuring things out. Yeah. Okay. All right, Zorn, let's see this one. Consider a system of endpoint masses with this Lagrangian. Determine how L transforms under the infinitesimal transformations of this, where omega is an arbitrary unit vector. Ooh.
I actually solved part A.
Oh, you did? Okay.
But part B confuses me.
I
also sent the solution in our chat. If you
did
want
you?
to look at it.
Which one is it? Oh,
yes, but it's sadly in a German.
Sadly, it's in the German.
So
okay.
The first file I sent you was problem set pre-exam, and then the one right beneath it with the number 22 on it.
Yeah.
That's the solution.
Oh, okay. Okay. I think I got it. So, wait. This is the question.
That's
and then this is going to be the solution coming up right here. This is the solution, yeah?
That's still the answer. Wait. I think. Wait, I'm confused.
This says LSG at the end. Is LSG the solution? I think LSG
just a moment.
Oh no. Yeah, just send it again.
Scroll a bit down further, just a tiny bit.
Tiny bit. Oh, is this the answer? Yes. They just restate the question again. Oh, I see.
Yeah.
Okay. Thanks, Nasser. You're very welcome, dude. Yes. I hope we cross paths again too. Yeah, I hope UCLA like hires me again. Like, we'll see. They got absolutely fucked like over the weekend with Trump pulled like $300 million in NSF and NIH grants to UCLA for like anti-Semitism. It was fucking bullshit. It's hilarious because like most of the professors that are losing all their funding are Jewish. So what? What's going on? Anyways, okay. Okay. B. Okay, but I need this in English. I don't understand this. Well, I mean, there's not that many words at least, Zorn, right? This is not too bad. Translate this, please. Nasser, you were interrogated for 4 hours? Oh my god. I'm sorry, dude. That sucks. Yeah, I do kind of count my blessings that I won like the genetic lottery of being like white and a guy. You know, like cops love me. Like I don't really deal with much in terms of like profiling or racism, which is nice. But I can only imagine with a name like Nasser Al-Soyan, you probably like flag all the fucking things in their system. So that sucks. I'm sorry you got interrogated for 4 hours. But that's also why do not leave the country right now. I have a lot of friends who are like trying to go to Europe or like France or whatnot for their vacations, and they don't have green card or they're not U.S. citizens, and they're canceling their trips because like it's not a good idea. You might get like kind of screwed with coming back, and that would be bad. All right, let's see what this is. Will I be teaching for Session C? No, I'm going to Burning Man. They wanted me to teach for Session C, and I turned it down because I was like, I need a little bit of a life this summer, and I'm very glad I did turn it down because otherwise that class would have been starting today. Session C started today, and I wouldn't even have this session done. It's insane. Yeah, so I'm very glad I turned down Session C. But okay, let's see. Determine the 3 conserved Noether charges corresponding to the transformation in 4 for omega is equal to... Okay, so this is a unit vector, right? And combine into them a vector value conserved quantity express the terms in terms of m, r sub s, and the total momentum of the n particles.
Did you understand A? At
No.
least the solution?
Yeah, I didn't understand A. Sorry. Do I need A to do B? Probably do, right?
Kind of.
Okay, let me just get this. Sorry, let me get part A. Let me translate. Translating. Oh, actually, we don't need this one. We need... There you go.
I'll quickly go on a pee break just a bit.
You're good. You're good. You're good. Yeah, go for a little break. Yeah, my friends are cooked, bro, and they be leaving the country and coming back soon. Yeah, don't do that. Just don't leave. Wait, you want to stay here. They're being really weird about immigrants. It's not even like immigrants, dude. It's like fucking like just like tourism at this point. Apparently, Vegas is down for like the 6th month in a row with income. Like, Vegas is not making any money because, lo and behold, nobody wants to travel to the U.S. anymore because they don't want to get detained for 4 hours. Yeah. Okay. The kinetic term transforms as... Okay. The World Cup is going to be dead? Yeah, probably. And the Olympics, right? Isn't the Olympics coming up too? I think the Olympics are in Los Angeles, no? Okay, so you square this, you get r dot squared, you get a cross term, and then you get this order epsilon squared, but we don't really care about that. Okay. So then the Lagrangian is equal to L plus...
I'm back.
Okay, you're good. Okay, so this term still survives from the original Lagrangian is what we're saying, yeah? But now you get this cross term, which, yes, okay, because that was 1/2 mv squared. So then that's m, but then this term is here. Okay, cool. And so now when you do... What's up?
The derivative with epsilon, yes, you have to take the derivative with respect to epsilon, and
Go ahead.
then the original Lagrangian disappears, and then, yes, you only get mk r dot k times omega. And then they want you to do like extra step with...
RK is equal to epsilon, like some error term, and then omega is, I guess, yes, some velocity times time, and then your initial velocity now gets added to... Why is this not times time as well, though? No, sorry. Yeah, no, it's a velocity vector. Got you. Okay, yeah. Okay. And then you do d epsilon of this, so you're right, this goes away.
Yes.
You pull out mk rk, r dot k, dot omega. Okay, oh, and then mr omega is the same thing as... wait, does the omega not depend on t? If we do this?
No.
No?
Because omega is just any unit vector.
1 sec.
Arbitrary unit vector, I call it. Omega is an arbitrary.
Oh,
unit.
okay. So yeah, so it's independent of that. Okay.
And
Sure.
the reason they pull out d dt is because d epsilon of L is the same thing as the time derivative of f, which is f is the thing in the Noether
The conserved
equation.
quantity?
Yeah.
Yeah. Oh, wait. Sorry. That comes back from this,
Yeah.
right?
So the part in the middle with goes away because we don't have time translation.
Yeah.
So the only thing that survives in part B of number 2 is the first part and f. And f is f is MRS omega.
Mrs. Omega, yes, Sibley. Doesn't look like Mrs. Omega, yeah. Okay. Okay, so that's DEDL, right? In terms of the total mass and the center of mass coordinates. Okay, sure. MRK. Okay. Oh, I see. When you sum this all up, you get a big total mass with some center of mass coordinate. Okay. I see. I think. Yes. Okay, that makes sense.
Well,
This is actually how you figure out
exactly.
center of mass, right? You just add up a bunch of point masses, and then you divide by the total mass.
Yeah, exactly.
Yeah. Oh, okay, cool. Okay, determine the 3 conserved Noether charges corresponding to the transformation. Okay, so RK is now x1, x2, x3k dude, what? Yo, what? Where is this coming from? Why are we doing transforms?
The t is just convenient to write. That's just a vector. That's just
Oh, okay.
RK is just x1, x2, x3. That's just
Okay, fine.
it's not a mat.
Oh, I get it. It's not actually a transform. They're just saying like this is like the vector form of this. Oh, okay, cool.
Yeah.
Okay. Xi goes to xi plus epsilon delta ijt. So then Noether charge is dl dx prime minus f. Why is it minus f? Oh, it is minus f. Okay, that's fine. Okay, and then because we got rid of these terms went away, right?
Yes, because we don't have time translation.
Okay, fine.
Well, in
is this a you know what I'm talking about? Is this a Dirac delta?
That's Kronecker delta.
Kronecker delta, sorry. Yeah. So it's like it's 0 unless those I equals j.
Yes.
Okay.
But the reason they did it is because what psi actually is omega t, omega it, I mean. And the way you find out what psi is, you just look at the factor of epsilon. And our transformation was r plus epsilon omega t. And that's why psi is omega it, and they call omega it Kronecker.
Kronecker delta, yeah. You do that in quantum, you'll use Kronecker deltas a lot. It's just a way of just picking out where the indices are the same. Okay. Roman says, what the actual hell is going on here? Zorn, you're scaring off so many people. I love it, dude. We're not scaring, but like it's provocative. Yeah, this is Lagrangian mechanics.
Well, I'm not trying to provoke people.
No, I know. Yeah, your teacher's provoking you, honestly. It's just hilarious. Okay, well, then F is equal to this. Physics is gross. This is high-level physics. This is almost like...
This is why they pulled out the time derivative earlier. So you can immediately read what F means. Because originally we had MRS dot times omega, and they just pulled it out, the time derivative. So you can immediately read what F is.
Oh, look, I forgot. We literally have a user in our Twitch called Hamiltonian Dynamics. Shouldn't the Kronecker delta be multiplying something with a J index? Yes.
Listen, man.
What are you talking about here?
Above everyone's head. So, like, it's a Kronecker delta ij is.
Oh, wait, but
omega.
But it is getting multiplied by omega. Omega has a J index, right? When we do this.
Omega is EJ, which you can see directly down below. They changed the.
Yes. Okay. Yeah. Okay. Got you. So then we sum Okay. But sorry. I is going from 1 to 3 because k goes from 1 to 3.
Yes.
Sure. And why does k go from 1 to n then? Oh, n particles. Oh, okay. Okay, so this is like the coordinate, and then this is like which particle, right? And this is like the coordinate. Okay. I see. This is for the kth particle. Yeah? That's the position of the
Yes.
kth particle? Okay. So, and then this Kronecker delta picks out... Oh, man. Who's teaching Dr. G? Zorn and I are like figuring this out together. Zorn is taking this as a class, so I haven't done this for probably 15 years. So I'm trying to remember it. Okay.
Well, I mean,
So-
down below, at least in the solution, they just take the
Yeah,
shortcut
I see.
and they say, well, xi is just rk. I mean, yes, r dot k.
Sure.
And then they change.
From here, right? And then this will only match up, right? For EJ.
Well, this is because I guess so. Yeah, I know that xi Kronecker delta ij becomes xj. Well,
Yes.
it should have been, but
Yeah.
that's
This
Kronecker rules.
Yeah, that's just Kronecker rules, right? Yeah. I has to equal j, so this has to only work when this is xj.
Well, and then mk rk dot becomes impulse p
Impulse,
times
sure.
ejt.
Sure.
What confuses me is the last part where they say, well, it's for every single component vector, so they just leave ej out of it, and then they just write pt minus mrs.
Well, because it's just a unit vector, right? Isn't
it's
EJ?
one,
It's a unit
obviously.
vector, so it's just
Yeah.
one, right? Yeah. So it just points
Yeah,
in the same direction
duh.
as P. Okay. And then this is MRS. Yeah. Someone's saying like, what? Here. I'll give it to Hamiltonian. Here's the original Lagrangian if you want to take a look at it. Okay. It's like kind of manageable, I think.
Okay, well, I get B now, but now take a look at C. If we can get C done, then I think I'm happy.
Okay.
Probably.
If you're happy, I'm happy, Zorn. So let's go figure it out. Wait a second, where was it? C. Use the result from part B to compute the center of mass rotation, RS. Eliminate the Noether charge in favor of RS0. Okay, I'm just going to look at the answer. Because I want to see what the fuck's happening. Roman, what are you doing? Don't answer those questions. Here, translate this as well.
Can he answer them, or
No, he's answering questions about the grades in my class.
yeah?
Roman's trolling. What happens
Wait,
if my? Because
from
that is a funny
I am
funny
from
physics
Germany.
joke. Yeah, he said the grade will collapse to one of the states. That is true. Roman is correct. If your grade is in between a cutoff, it does collapse to one of the cutoffs.
What's the Lagrangian? Okay, tough.
All right, let's pull this in. Okay. All right, so let's see. For part C, use a result from part B. So this was the result from part B, right?
Yes.
MRST is equal to is equal to PT plus Q. Wait, one second. First of all, excuse me, what? Does this even make sense?
Well, they say to eliminate Q in favor
okay,
of
okay.
So, but I don't know what's going on.
P equals m r dot s, right? So then you have Q
Yes.
is equal to m r dot s t minus m r s.
Yes.
So this, so MRS dot is equal to Q plus MRS. Okay, I'm cool with that. Sure. And then what they say is that eliminate the Noether charge in favor of RS 0. So I guess they're saying eliminate this, and just instead of saying RS of t, you just say this is RS of 0, maybe. Well, no, because it's still here.
I think they mean Q literally. Like
Oh wait,
like
no. Q is the Noether charge, right?
Yes.
Yes. Q equals Q0 equals negative MRS 0. Sure. Okay, and then they just solve for RS. And so they say that RS is equal to your like initial velocity times t plus your initial position. I guess that makes sense, right? Your position's equal to your initial velocity times t plus like whatever your initial position was.
The first equation you wrote, I guess I can understand it. What they did is just MRS dot t is equal to Q minus MRS, and a plus MRS t, and then I don't get.
You don't understand this part?
Oh, the one before.
Here?
One line above. Yes.
Yeah, so all they do here is, so instead of Q, they replace it with this. Okay? So you have R dot S T is equal to negative MRS 0, right? Plus MRS of T. Okay. So then you can cancel all the M's out. M's go away, right? That's nice. So then
Why is Q equal to negative MRS 0?
So watch. So now, oh, sorry, why is Q equal to negative MRS of 0?
Yes.
From here. Right? So Q of 0, right? Time is 0. This goes away. Right?
Obviously. I'm such a dumbass sometimes.
No, you're not a dumbass, dude. You're really smart, dude.
Because Q is conserved, QT equals Q0 for all of it. You know what, Hamiltonian? How about you come and do this?
Q is conserved because QT equals Q0 for all t. I agree with that. Yeah, because dQdt is 0, right? Okay.
Now I get it. If t is 0, you get it. Yeah, okay.
Good. Yeah, and then you get to this, right? And this is so funny because this is just like really, really big fancy math for just this basic ass equation, right? Your position's equal to your initial position plus the velocity times time. Right? This is assuming that your velocity is constant.
I get it now.
Nice. Cool. I'm glad. I'm glad you get it, Warren.
It's really those small details you mentioned that will help me understand some of it, because
it's yeah. And honestly, again, it really helps to see the solutions and to be able to kind of like pick out like what's happening, and then also just hearing yourself say it to other people, even if, again, I probably understand like 30% of this. But it's almost like kind of like therapy. If you just like hear yourself saying things out loud, you're like, oh, that actually makes sense now.
I mean, even the higher ups at my university, they all say that you basically don't understand anything until you're like in semester 5, and then just some things click. Because I myself, I learned better when I just learn how to compute things, and then I watch a video explaining what it actually does.
Yeah, that's called learning. You learn the procedural thing first, then you like try to use that to make sense of the conceptual, and then the final thing is to like apply it to something else. That's the third step of learning. Yeah. Hamiltonian says this is a tricky one because What's up? Go on, Zorn.
Well, I have ADHD.
You're fine.
So
Everyone does.
first of all, I get a separate room to write my exam and 30 more minutes. Also, I have my medication, and with some Red Bull and my medication, I'm going to be good, I think.
Hell yeah, dude. Yeah. And 30 extra minutes. That's nice of them. Yeah.
Someone asks, what class is this for? Man, this is theoretical
really hard.
physics.
Yeah. This is
I
hardcore
think
physics.
in America, when I'm on TikTok, I see people just saying like, oh, there's a differential equation class, a Calc 3 class.
Yeah.
But in Germany, we don't have that. We call everything just higher math, or
Yeah.
I mean in theoretical physics. There's so many topics you have to learn. There's like we can't even split them up because it would just, I don't know, make them.
It would take too much time.
Too big.
Yeah.
Yeah.
Yeah. So you're kind of getting like a crash course in. This looks to me like, again, Lagrangian mechanics is what it is.
It is.
But
I mean, if you look at number 3, 4, and 5, in the problem sheet I sent you in English, like for example, number 3 is
Smurfs on the
calculus.
run. Smurfs are fleeing from Gargamel, dude. What the fuck?
I mean, this number I've memorized it, so I know how to do it. And then number 4 is something sliding apparently.
This is a classic question, dude. They love this one in physics. The bead.
I know.
On a rotating wire. Yeah. Oh, dude. Roman says KIT is a legendary place. This is where you go to school, yeah? You go to this school?
Oh yes, I go to. Damn.
Yeah, there's your school.
KIT?
Yeah. Karlsruhe Institute of Technology. Yeah, Roman says it's a legendary place, dude. That's cool.
Just FYI, can you maybe, because I forgot to mention it, just I think I can't actually send it or share it because of security reasons.
Oh, you're fine.
But I guess it's fine.
I'll scrub it. Don't worry. You DM'd everything to me anyways.
But Roman, I have a quick question for Roman. Do you know KIT?
Roman, do you know KIT?
Place.
He says it's a legendary place.
Okay. I think the guy who made Mercedes-Benz went to KIT, but...
Ooh, that's cool. Nice. Okay. Roman says who doesn't? I apparently don't know.
Shit.
I don't know where KIT is. I don't know where it is.
Well, it's in the good city of Karlsruhe in Baden-Württemberg.
I've only been to Berlin.
And Heidelberg.
I think I have been to Heidelberg, maybe.
Yes. How can I know that and you don't?
So so this is the book that Hamiltonian Dynamics recommends by Highwell and Sahakian. Modern Classical Mechanics. Oh.
Quick screenshot of this book.
Yeah, you're good.
Like with your face on it, nice.
And my prices, $59 in the US. That's nice.
I mean, I probably can't order this book and read it till my exam, but who knows? Maybe I'll.
Maybe for later stuff, especially if you keep doing like more like theoretical physics. Yeah. Yes, Armenian. Yes, I can definitely tell he's Armenian. Anything that ends in like IAN or YAN is automatically Armenian. Yeah. Sahakian. That's cool. Who's this guy? I'm gonna go find him. Okay, cool. Well, Soren, get some sleep. You can hang around if you want, but like also like rest up before your exam. Yeah.
Well, I will still look at the other questions like number 3, 4, and 5.
Yeah.
And write a quick summary of them, and then I get some sleep.
Okay, nice.
And then I'm going to take my Red Bull overdose and then do the exam.
Hell yeah, dude. Stim it up, Ray. Stim it up. All right. Good luck, Zorn.
Thank you very much. Thanks for your help.
Yeah, you're very welcome, dude.
Goodbye.
Meeson says, yeah, that was Zorn, one of our students from Germany, in a very high level physics class. It's kind of a workout for me to do that. Yeah. What's up, Equity? Good to see you too. Sorry, let me go through a little bit of the chat. Yashir says, so it rounds to the nearest cutoff. No. Grade cutoffs are grade cutoffs, which means that like you have to have that grade in order to get that grade, right? Yeah. I'd probably have where's the standard UCLA grade cutoff? Yeah. Here we go. They sometimes have where's the standard grade cutoffs? Yeah, I know what that is. Here you go. This is the standard one they use. No, where is it? Oh, man. Fine, I'll go find it in my syllabus. Dun 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 dun. What? No, that is my passcode. Come on. What the fuck? Oh, that's it. There we go. Okay. So, in my course, if we go to the syllabus, this is the cutoff. Yeah, that's what it is. If you were asking there, Yashir. So, what happens if you're in between a cutoff? It goes down to the one you just beat, right? So, for instance, if you had like a 78, that's in between these two, that's a C+, you know? Even if it's like a 79.5, it's still technically a C+. The reason for this is we also give out like a lot of opportunities for like bonus credit at the beginning of the class, like extra credit stuff. Like, so if you did the surveys, if you were, active on Campus Wire, helping out other students or getting help, and then if you did the syllabus quiz at the beginning, I think that equates to like 0.6 amounts of points. So that would already be like the bump you need to like get rounded up to like whatever one you want. Do a lot of people get A pluses? Some people do. Yeah, for sure. Especially like in my spring quarter class, I had a lot of extra credit like on the exams that I gave out. And so some people would get like 105s on the exams just because they'd already taken physics. And so like this class was cheese for them. But a lot of my students have never taken physics ever in last quarter in the 5A class. So yeah, some people got A pluses, I think I had a grade distribution. I just did it. Yeah, here we go. This was the ending, and also this grade is not final because I still have students submitting requests to get more partial credit for exam 2 and also more partial credit on the final exam they just took. But as it follows, this is the number of students that have the different like grade distributions. So yeah, 6 people in the class have an A+, 28 people have an A, which GPA wise, these are the same thing. 16 have an A-, 13 have a B+, 10 have a B, 6 B-, 5 C+, 1 C, 4 C-, 1 D+, 2 D-, and 2 Fs. Although I imagine those Fs are people that dropped the class. So I don't know. I'll have to look at it. The regrade requests will totally help. Yes. This is before we did exam 2 regrade requests and the final exam regrade requests. So these numbers will move. But this is overall what the class is at so far. So if people ask me like, how's the class distribution? It's pretty good, honestly. The department wants us to like shoot for a 3.1 average GPA for the class. It's to deal with like grade inflation and also like grade deflation. So if, they don't want, and I get kind of like about this because this to me is like kind of like a curve, but they don't want to give out all like A pluses to a class because then it starts to screw up with like grade inflation stuff. How I like design the class is that I don't ever curve things, but there does tend to be a bell curve that just occurs from again, things like effort and people putting in the time, turning in things on time, showing up to lectures, like answering questions, all that stuff does eventually make like a bell curve. That if you design the class right, you can hit that 3.1 class GPA without having to artificially like put in curves to curve up or curve down. That's the worst thing. If you're like too generous with points during like the course of your class, and then your class GPA ends up being like a 3.7, you're then forced to curve the class down, which means that now people have to get a lower grade than what they actually got. And I hate doing that. And so like, I have never had to do that, but I know it does happen to some classes. So yeah, y'all be fun. Let me answer some questions. How hard is physics for people that are transferring, and what are regrade requests? Depends where you're transferring from. If you're transferring from Mizan, you're a very smart guy. I remember you talked to me about like all your physics experiments and stuff. You're going to be totally fine. For some people that are transferring from different institutions where maybe they never took physics or they haven't taken a high enough level of math, physics can be tough because it is very dependent on your mathematical background. And then again, if you've taken any physics classes, usually in high school you take physics. Some high schools again offer AP Physics, whether that's AP Physics 1 or AP Physics C. If you've taken those, then a college level class like the one I just taught is actually pretty easy. It's not very hard. I teach like intro undergraduate level physics, and if you've taken AP Physics in high school, you're going to be pretty much fine taking the class in college. The thing I struggle with is that there is a significant portion of my students who have never taken a physics class before. I don't know how. But apparently some high schools like just bundle it as like some integrated science, whatever bullshit class, and they just never learned it. And so I have to kind of teach from the ground up for certain courses. Yeah. Curve grading wasn't even allowed at my university. I don't like curves. I'm going to write a whole LinkedIn post about like why I don't like curves. Mainly because they just pit students against each other. Because then instead of like trying to do well, you just try to do better than your friend, who then becomes not your friend. Because you're like trying to like screw each other over. It's terrible. I don't like curves. I was away for a few years. I think once I take more math. Yes, exactly. Yes, and also it's very highly dependent on how much math you've taken and how recent that was. And then Mizan, the regrade requests are, so like whenever I grade the exams, I give like some base level of partial credit for people just at least trying a question. And then I make it as an exercise for the student to go through the solutions, go through their exam, see what they did wrong, and then explain to me why they think they should get more partial credit. And this works in a multitude of benefits. Like, the student has to like go through and figure out what they did wrong, and that's a very big teaching thing. It's a great teaching moment for you to realize I made a mistake. Here's what I should have done. I'm not going to make the mistake again. And then also, from a grading point of view, it saves me a significant amount of time because now I'm not hunting through everybody's exams trying to figure out where they messed up. You know, if you show me where you messed up and you're like, oh, it was just like a simple, like I screwed up on a calculator here. Cool, awesome. Then I can just give you points, and it's a win-win is what it is. So, Omega says, how is it possible that any science course doesn't have physics at all? What is integrated sciences about? Collecting stamps? Yeah, it's called IPM, Integrated Physics and Math. They take it in some high schools, and it's a very cursory intro level to physics. There's barely any math involved with it. You may do like rate of change, like speed is position over time or something, but you're not doing much in terms of like drawing force diagrams or like deriving equations. Certainly not doing any calculus in those classes. And so that can be rough when a student comes to the university level and has to suddenly take a calculus-based physics class. I don't know. Our education system is great sometimes, and then it's abysmal at others. Just really depends where you go to school and stuff. And this is why it's very important to, this is why parents, when they're, picking a place to live, tend to look at what the school district is. They tend to look at like, okay, where is my kid going to start learning things? Because, it matters a lot. I was fortunate enough that I got accepted to a magnet science high school when I was young. And that put me in specialized classes where I learned, like, again, advanced math and science stuff from people who gave a shit about teaching advanced math and science. And also all of my classmates were similar driven math science people. And so if you're surrounded by that and you're in an environment of great teachers, you're going to have a pretty good chance at doing well in those things once you get to college. We need to clone Dr. Gold because none of my classes had partial credit or anything. Yeah, I know. Yeah, it's because it's much easier for teachers just to say it's right or wrong and then be like tough, and then what they do is they curve at the end. That is what they do. So I call it, this is very lazy teaching is what this is. But yeah, there's no partial credit. It's either right or wrong. And then in order to like make up for their lack of actually giving partial credit, they just curve the class at the end, which I think is terrible because now you're like conditioning students to, get like a 50 or a 60 and like throughout their whole life, they've thought if I get a 50 or 60, like I failed, like I'm terrible, I'm awful. Right. But then that becomes like the norm. And it's just it's very weird for students, especially in high school or like earlier classes where you probably had more partial credit, but you'll get to like some college level classes where like some crotchety old professor just does not want to put any effort into teaching. And it's either right or wrong. It's either yes or no. And the way they just keep, the class from absolutely revolting is they just curve everything up at the end. And it's garbage. Like, yeah. So, yeah. Do you have kids, Gold? No. I mean, I say I have 1,800 kids in my Discord, but
no. You done messed up, Aaron!
I don't have any like genetic children that I know of. But someday we'll see. I don't know. Busy these days. 60% of what? Do you fear that AI will make professors obsolete in the future? No. I think. I think AI has the potential to again make effective teaching like easier. So, for instance, I spent a good amount of time this weekend trying to get all the grades from like one LMS system into another LMS system. And that is not me teaching. That's not physics. That's me doing like administrative work. And thank God I had AI in order to like make that process a lot easier. Otherwise, I'd be manually going through like 100 students with 50 different assignments and having to like manually put stuff over and whatnot. It would suck. But AI like enables me to do that a lot quicker so that I can then focus on actually teaching. Exactly. Creating quizzes is another great thing. I'll show you an example. I do this when I tutor as well, students who have poor teachers that don't give them study guides. So, for instance, where was it? I did it somewhere here. Yeah. So, I had a student that was taking a chemistry test, right? And they didn't give him any sort of practice test, no whatever. They just gave them this like, here are the topics that are going to be on the test. Like, good luck, have fun, like try. And what I did was, if you use ChatGPT's research function here, it will like search the internet and do like a lot of like deep AI stuff. And so what I said, hey, like I have a student at SMC. They're taking a chemistry exam. Could you create a 30 question sample exam? Here's a screenshot of the topics. And then I want it to be multiple choice. And then it asks some follow-up questions like, hey, do you want me to ensure all the chapters are equally distributed? Do you want to include any topics? Do you want to match the difficulty? I said ACS, which I think is American Chemical Society. And it did it. It created now, this took 23 minutes. So, and you only get like 30 of these per month. But if you use the deep research function on ChatGPT, it will go search through the internet and like through a bunch of things, and it will also do bigger requests. So I said, create me a 30 question. If you do this in regular ChatGPT, it'll stop. It'll be I'm only going to generate like 3. Like screw you, dog. But if you use the research function, you can get it to work at things for like 20, 30 minutes, and it created a whole practice exam. So this was very useful. The student ended up taking the practice exam. We went over it, and then they, ended up getting an A in the class. So that's an example of like AI can be very helpful for teachers. Did that replace me as a teacher? No, because first of all, the student had no fucking clue to do that. Like I had to be the one to say like, okay, well, I know what we need to prompt the AI. I know what we need to do to build the practice test, and then when they get things wrong and they need someone to explain it, sure, they could have used AI to get it to explain it to them, but at the end of the day, like humans still prefer humans. There's a reason that like, you know, we haven't completely started like just dating like AI waifus and whatnot. We still prefer actual human interaction, and so I think that from a teacher will never get replaced. I think the effectiveness of a human can be, you know, augmented amazingly, which is awesome. But yeah, that is not the free ChatGPT. No, I pay for that for sure. Yes, AI makes it easier for self-taught learners. Yeah. If you're self-taught, yeah, great. And if you have the self-discipline to do things yourself, then you're great. Yeah. According to Asimov, there's no other learning than self-learning. Yeah. I mean, at the end of the day, you do have to learn things yourself. Humans prefer human, especially human faces, voice, especially the ones considered beautiful. Yes. Well, you know, I'm not the ugliest thing in the world. But beauty is also dependent on the beholder, Omega, right? You know, it can be physical beauty. I tend to think of like intelligence is very beautiful for me too. If I meet someone and they have like a really interesting brain and they can come up with really cool like thoughts, that adds like points in what I call like the beauty scale of someone. I'm just like, oh, okay, cool. You're actually like really fun to talk with and I don't know, intellectually stimulating. Yeah, you're good, Nasser. Appreciate that. Do a lat spread, Dr. G. I'm going to the gym later. I could not go to the gym today because I was grading. It's also nice to verify what ChatGPT says with other people like yourself. Yes, exactly. Yeah, it's great for sanity checking. Have you heard that ChatGPT and Claude illegally downloaded terabytes of data? Yeah, I don't care. Whatever. Like, ethics? Are we really confused? If we're really concerned about the ethics of how these things are being developed, like, we shouldn't be using any of them, because these things are absolutely terrible for the environment. Like, data centers consume massive amounts of power and like water, and they're absolutely awful, right? Yeah, but yeah, all data is like stolen at this point. Yeah, Twitch steals our data. Yeah, your data is getting stolen right now. You know. Yeah. Okay, sorry, let me go a little bit through more of the chat. The stamp collecting. Do you know the quote, the stamp collecting one? I think it's like all science is math or physics, the rest of it is just stamp collecting. Or it's physics or stamp collecting. Is that what it is? Yeah, it was Rutherford. Yeah, all science is either physics or stamp collecting. Yeah. They joke about, because like in biology you're just like collecting facts. You're not really like processing things. At least not in the early classes. Yeah. Yes. Yeah, embrace it. That's just yeah. It's okay. Yeah, my personal address is like very easy to find on the internet because it's registered to this nonprofit. So all my information is out there. Okay, let me make sure the YouTube chat was okay. Okay, cool. Yeah, people steal. You got to be kind of vigilant, you know. Check your credit reports if you're old enough to have one. Yeah, because people can do bad things with things. Let me see. We got any questions from the students? Ooh, yeah, Equity. Equity, do you need help, Equity? Bob Ross's? Gold, do you think it's better to take Calc AB or Calc BC? Calc BC. 100%. Take BC. You get an AB subscore anyways from taking BC Calc. So you just might as well do it, is what I say. Okay, let's see. I think these are cool questions. These are like systems of equations and stuff. Okay, cool. But yeah, keep up the discussions in the chat. I'll answer them as we do as I go on. This is what's called like a 3x3 kind of, yeah. A 3 variable systems of equations that they want you to solve. So there's a bunch of different techniques you can use. There's basic substitution you can do. There's row reduced echelon form that you can use as well. Depends like what you're allowed to use. Equity, Gaussian, yeah, you can use Gaussian elimination. Gaussian elimination, is that what it is? Yeah. Yeah. So yeah, a couple ways you can do this. You can take this first guessing. No, we're not gonna be guessing. No, don't do it. AP pre-calculus is a money grab. I don't think you need to know. Well, you need to know things from AP pre-calc, but you don't have to have taken AP pre-calc to do calculus. You only know substitution and elimination? Okay, cool. So those methods work. They're just kind of like they're kind of slow and like not very pretty, and they're like brute force-ish and whatnot. Zach says the probability of a solution being the triple integer. Yeah, that exactly, right? And being just integers. Yeah. Sorry, let me shout you out, Zach, by the way. Zach is the expert on probably the BC calc versus AB calc difference because it involves sequences and series, which Zach wrote like a thesis dissertation on it. He wrote a dissertation on like how to teach the part of BC calc that everyone gets screwed up on, which is infinite series and sequences. So, Zach is dad. Yeah, Zach is great. Zach is actually a dad. Yeah. So one way to do this, right, would be to say, okay, from this form here, you could say that x is equal to 1 minus 4z, right? And then you could plug that in to here. So you could say, okay, 1 minus 4z plus y plus 10z is equal to 10. And then you have, you'd also need to plug it into this one, right? So then you'd say, okay, 2 times 1 minus 4z minus y plus 2z is equal to negative 5. You don't really need to know matrices for BC Calc. I don't even think you really need to know vectors. Maybe parameterization. Okay. So from this, what do you get here? You get y plus 6z is equal to 9, right? So if you move that over, combine that with that, leave that. This becomes 2 minus 8z. So this becomes minus 6z. And then this is minus y. Oh, is this about to be... I don't like this. This is scary. Oh, no. I feel like this is equals... Is this no solution? Did we screw up here? One sec. Minus 8z plus 2z is minus 6z. Minus y, cool, 2. So this is negative 7. What happened here? Minus 4z, so that's 6z. That's plus y equals 9. Yeah, vectors, yeah. And then, let me see. 2 minus 8z minus y plus 2z. Just make sure I'm not crazy here. Yeah. Okay, so this is a problem here, though, right? Because this is like no solution. Right? You can't have y plus 6z equals 9, but minus y minus 6z equal negative 7. Unless I screwed up somewhere, which I don't think I did. Let's check it out real quick. I'm gonna throw it in a matrix real quick, just to see. I may have screwed up. Matrix. 3 by 4. 1, 0, 4. Oh, you're right. There's no solution. Okay, cool. Okay, I was just, yeah. Okay, so the reason why equity there's no solution is that once you take this and you plug it into here and you plug it into here, you get two expressions that they're not consistent. They don't make sense with each other. Right? Because if I do this, and let's say like I add these two together with the elimination method, I get 0 plus 0 is equal to 2. You can't have that, dude. It's just not right. It's a big pile of shit, dude. Yeah. Okay.
That is one big pile of shit.
That's too funny that like they gave you that question. What's the system again? This is the system. How do we determine if there's no solution? Is the determinant 0? Stephen W. Web app, and yeah, I mean the other way to do it is to use a calculator, right? You can do it this way with matrices. So this is 1 0 4 1, and then 1 1 10 10, and then 2 -1 2 -5, and I bet when you RREF this, you get something weird. Yeah, you get 1 0 4 0 0 1 6 0 and then 0 0 0 1. Yeah, this doesn't make any sense, right? You can't have 0x plus 0y plus 0z equal 1. Yeah, that doesn't work. Oh, what's the trick? What's the trick, Zach? Is the trick that I have to do the determinant? Because the determinant already like kind of sucks, right? 3x3s aren't the easiest things in the world, right? What's the trick, Zach? I'm assuming it involves something like this. Use the diagonals trick. Am I doing it of just this one? Just the 3x3, not the augment? Let's see, diagonals. Oh, thank you. Okay. Yeah, I've seen this one before. Yeah, this is the wacky way to do determinants. Yes, Nick, I won't forget about you. Yeah, dude, what do you, sorry, how does this work again? Okay, so if we have, let me just pull this. And then, okay, so you repeat the next two is what you do, right? So then this is 1 0 1 1, and then this is 2 -1, and then you do I think I see here, you do like diagonal diagonal diagonal, and then these are the -1s. Okay. So what do you get? Oh, and you multiply them all together. Okay, so that's 2, 0, -4. And that's 8, -10, 0. So that gets me -2, and then we get minus -2 equals 0.
Oh no.
That's kind of cool. Wow. Perfect. It's like a mobile game snake. Yeah. The real mobile game snake is how you do oh, it says you calculate the odd even permutations as positive and the odd permutations as negative. Oh, that's cool. I see. ABC, BCA. And then you do ABC. I see. Yeah, talk about it on Wednesday. Yeah. Yeah, make sure. Yeah, if you're just finding us from all sorts of sources, whether it's YouTube or Twitch, I'm not the only person that does this. We have a whole other like selection group of math people that do streams, and so I think Zach is on the schedule for Wednesday. So yeah, Zach's going to have a stream at noon on Wednesday. If you want to go check it out, there's the calendar. Make sure to go like add his Twitch and stuff. So he does have a cool like. Some people get like, where's Jeff? Jeff's always upset that I'm doing so much physics now during my streams, and he's like, "Where's the math?" Zach has more of the math. Yeah. Okay. So yeah, if the determinant of this thing is 0, you can't actually solve it. And then I think the reason for that is that it's not invertible, right? So if you think about this as like a matrix A, and then this is well, here, let me use the right colors here. This is matrix A, and then this is considered well, here, okay. You have this, and then times what we call like X, and then this is really X, Y, Z is what it is. And then we say is equal to this. This is like matrix B. And in order to solve for what X is equal to, you have to, the same as we do in algebra, right? If I had like AX is equal to B and you wanted to solve for X, you would just divide by A, right? That's a very easy way to solve for X. But the other way to think of that is instead of dividing by A, you're multiplying by the inverse of A. And so really what you're doing is you're operating A inverse on both sides. So this goes away. And then you would just get that matrix X is equal to, we say like A inverse B. But then here's the issue, is that if the determinant of A is equal to 0, then A inverse is impossible. You can't invert the matrix. And that has to kind of go for, I think like, what is it? The determinant of a matrix of a 3x3 is like 1 over the determinant of A, and then it's like times like some fancy shit that happens, right? And if this is like 1 over 0, things like screw up. Yeah. Yeah, if we divide by A, it's the same as multiplying by A inverse. Why do you have vectors on top of the matrices? I don't know. I just wrote them like that. You're right that they're actually just matrices. I'm this is me used to physics land. I'm just putting matrices. I'm putting the vector symbol on a bunch of stuff. Yeah. Yeah, Jeff's like, where's the math? Okay. Cool. Anyways, that's a cool question, Equity. So yeah, that one's not solvable. The other ones probably are. And there's other ways to do it, but I can do more of those later. Let me make sure I gotta help Nick, because I missed teaching Nick on Wednesday, and I do have to tutor another student in physics, funny enough, in 30 minutes. So let me help out Nick real quick. But this is good stuff, Equity. I can show you all the other cool ways to solve these later. Descendant fonts. Exclamation Q. What does exclamation Q do? What do you think exclamation Q does, descendant fonts? Okay. Nick, what's up? You here? I'm gonna ping you. Ping you, Nick. Oh, questions. Yeah, that would be a cool thing. I wonder if I could have something with a webhook there, descendant fonts, to like show like what the queue of questions are. Okay. Let me help you out, Nick. Yeah?
Can you hear me?
I can hear you. Your audio is kind of garbled. I'm hearing myself a lot. It hurts my ears.
I'm gonna change the phone then.
Okay. Oh, that's cool, Jeff. Yeah, I gotta figure out how to do that. How we do the questions, it's a little scattered. Yeah, because I have so far, like, so I have help screenshots. This is where students, like, submit questions. Then I have web help screenshots. So this is where HHH has submitted some really fun circuit things for me to do. This had, like, current sources in it, yeah. And then I also have, like, sometimes students just, like, send me DMs, which that's the least effective way for me to remember to help you. But it's okay, Nick. Go find where he is. SR, Fermat's last theorem. I remember watching the documentary about the guy that solved Fermat's last theorem. It was recent, right? It was in the last like 20 years probably. And apparently it like completely broke down his relationship though with his wife or something. Because he was just absolutely consumed by the math. Yeah, Andrew Wiles, that's it. Yeah. Like he's just sitting up there in his room, just constantly like toiling away with like pen and paper. Meanwhile, his wife is like, "Come down for dinner, please." He's like, "I can't. The science has me. The numbers got me."
Yeah.
All right, what's up? Let's see.
Is this better?
Yes.
Okay.
He wasn't even trying to solve that problem? Oh, what's the lore, dude? Richard Taylor and Grothendieck. Oh, Jeff, I bet that makes you really happy, dude. He was doing stuff with elliptical curves. Jeff loves non-Euclidean space.
My man.
He's a big fan of any sort of like spherical geometry he can work with. Jeff likes his math thick with like 4 C's. 4 curvature. Okay, let's see. The Earth is round, dang it. All right, Nick. Questions 33 through 40 are to be answered on the basis of the material contained in the Index of Crime in Central City, USA. Okay. Some things remain blank. Okay. Okay. Nice. Property crime. Theft. Larceny. So yeah, background for those that are watching, Nick is training to take a test to become a court officer, and this is like part of the practice test that he's trying to study for. So I helped him out with some of the questions to learn. Okay, property crimes. What was the total number of property crimes for 1994? Ooh. Okay, how do you think we get that, Nick? How are we going to figure out the total number of property crimes? Well, first of all, like let's figure out where property crimes are in our table, right? You see how property crimes are in this column?
Yeah.
Okay. And then 1994 is like here. Yeah.
Mhm.
So how do I figure out this missing thing here?
This one is a little bit weird. You see the 1 and 2 on top of the crime?
Mm-hmm.
They are separate from the rest of the table.
Oh, they are.
Yeah. It took me a while to understand that.
Wait, where is that in the question? Where does it say that?
It doesn't show that. I don't know why.
What?
So
No.
index crime total is the total of 1 and 2, and is also the total of murder, forcible rape, robbery, and everything else.
What?
I don't know.
If you subtract the first column minus the second column, you get... Okay, oh. The other way to do this, yeah. So even if that wasn't told to us, Nick, what we can do is we can look at how like other numbers are computed, right? Do you see how this minus this gets you this?
Yeah. It took me a while.
That's whack. So
Yeah.
I think all of this is... Well, wait, no. I think this right here is violent crime, and I think this is property crime, maybe. Do we think burglary is property crime? Yeah. Were you laughing at violent crime, Dr. Gold? Uh-oh. Don't cancel me, please. This table layout is a crime, dude. Yeah, this is absolutely awful. Okay. Yeah. I think interesting. Yeah, you're supposed to like kind of imply it from looking at the things. Burglary is when you're not there, so it's not violent crime, right? That would be more like aggravated assault, maybe. Also, we can see this. Do you see how these numbers add up probably to this, but not with this as well? If we added this in with this would be way over 1,000. Do you see that, Nick?
Yeah.
Yeah. Okay, cool. Oh, robbery is violent. Yes, there we go. Yes, robbery is like burglary, but when you're there. Okay, so yeah, if we want to figure out property crime, we just do crime total minus violent crime. Learning so many things today. We were learning like Lagrangians and like Hamiltonians and stuff. Now I'm learning about like crime statistics. All right, 7842. Answer choice D, yeah?
That's dope.
Nice. Cool. All right, we got that one. Nice. What was the total number of burglaries for 1995? Okay. So that's 1995, and then burglaries is going to be like over here. Ooh. Okay. Well, I know that these three things, right, should add up to this, because those three things are property crime. Yeah, exactly. So that's 9278 minus 5262 minus 977. So that's 3039. Yeah. Okay. That's not too bad. Here, I'll like kind of write out like what we did for the math here so you can remember it. So this is oh no. Oh, I don't want to rotate you. Oh dear. Oh no. Okay. That was equal to 8717 minus 875. Looking at crime from another angle. Wow. That's really good. I appreciate the pun there. And then this was burglaries in 1995. Oh, yeah. So that was 9278 minus 5262 minus 977. Okay, cool. In 2003, the number of aggravated assaults was most nearly what percentage of the total number of violent crimes that year? Okay, so let's go to 2003. So aggravated assaults was 650. And total number of violent crimes was 1,285. Okay, so you got to divide that. So 650 divided by 1285. What's non-aggravated assault?
I have no idea.
Like assault that wasn't, I don't know, maybe like random assault, you know? Like aggravated means like someone like kind of pushed you into it, right?
No idea.
Like if someone aggravates me, right? Yeah, casual assault. Yeah. Like
Casual assault is crazy, yo.
a mild case of the ultraviolence. Okay. In 1998, property crime. So property crime was 9926. Crime index total. So that was 10935. That's going to be very high. $90.7. Yes. Is this still 1B? No. This is learning how to be a court officer. What's the total number of property crimes for 1997? Okay, so then we just got to add up all these numbers. So that's equal to 3089 plus 6270 plus 959. $10,318. Nice. Total number of robberies for 2001. Ooh, that's this. So Abu, it's in the it's in my announcement, but regrade requests for the final are Thursday night. Thursday at midnight, my time. So 2001. Okay, so that's kind of annoying to do all that, man. 1308. And then you got to subtract all the other ones. So minus 230, minus 23, minus 83, minus 654. Yeah, I don't know where footnote 1 and 2 are, though. Oh, that's 548. Nice. Robbery made up what percentage of the total? What percent of the total number of violent crimes for 2003? 536 over 1285. That's going to be 41.7%. Nice. And what is the total number of forcible rapes for 1996? Oh, dear. So that's this. So that's going to be 10 to 30. Minus 20. Minus 465. Minus 485. So 10 to 30. Minus 20. Minus 465. Minus 485. 92. Well, that's not good. Wait, whoa. Wait, for 1996. Oh, I need to do violent crime, not property crime. Sorry. See, even I would have got one of these wrong. Oh, man. All right, 1026. Nice. 56. Good. Okay, there you go, Nick. I'll save it, send it to you.
Nice.
When's your test for this, by the way?
September, somewhere around September.
Okay. Well, it's coming up in like a month, man, dude. That shit'll creep up on you real quick, dude.
Yeah.
Here, let me add this into here. Okay, cool. Nice. Let me see. Let's see if we can do this question from HHH. And then I gotta go. You're welcome, Nick. Okay. More math for you, Jeff. Seek power series solutions to the equation about the point x naught equals 0. Find the recurrence relation to generate the coefficients, and find the first three non-zero terms in each of the solutions y1 and y2. Zach loves power series. That's his thing, dude, right? Yeah. Okay. Is there a power series struggle here? Oh, a power struggle. Jeff is on fire today with the jokes. Oh my god, dude. Okay. Okay. This is not separable, right? Unfortunately. So, yeah, how do we do a power series for this? Oh, I see. this is kind of like a Fourier transform, right? Is what it is. So for instance, y of x, yeah, is ai x to the I for I 0 to infinity. Yeah, okay. Thank you guys. Yeah. So we're gonna say an x to the n equals 0 to infinity, and it's about 0, right? So I don't have to do like some x minus x naught thing here. Yeah. And then I remember like how I take derivatives. So y prime of x. So bring the power down. So that's gonna be an n or times n, right? And I think you start this at 1 now. Is that correct, right? Because the 0th term goes away. And then this is x to the n minus 1. Okay, right. Sines and cosines, yeah. Right, because x to the 0 derivative is not exactly. Yes. So then this will be n equals 2. And that's going to be a to the n. And then we have n minus 1, x to the n minus 2. Yay! What's up, Obi? Thanks for the raid, bro. He's like, I see some differential equations. We got to go after it. Nice to see you, Obi. Ending the stream on some math today. I did a lot of physics earlier. But shout out to Obi. Obi's a great guy. If you want to learn more math and stuff, he's there. Okay, so then let's like substitute in, I guess, right? Okay, so I have this. Here, can I grab all this? No. You go up here. So this was y, no, y double prime is this other one. Sorry, my bad. Okay. I should have spaced these out more. Okay. So we have this. Plus 2x times this plus 2y yeah, hopefully they like kind of like they're kind of nice. And that's all equal to 0. Okay, so the x is going to come in, and that's going to make this an x to the n, right? So we can get rid of this. Oh, here, let me just copy this all down. So this is going to go away. This becomes x to the n. That's going to stay like that. Mm-hmm. And then I think I want to try to re-index these, right? I want these all to have the same... Oh, yeah, I want these all to have the same index so that I can combine them. If you pull n equals 0 from the last term, you can combine the last two terms. Exactly, right. So this is the same thing as a0 x to the 0, so that's just times 1. So that's that, 2, plus 2 summation n equals 1 to infinity, a to the n, x to the n. Either or, okay, cool. Yeah, so if I were to start writing out the terms for this, the 0th term is just this one. And then now I can combine this one and this one together, right? So that's going to be, so we have plus 2 summation n equals 1 to infinity. And that's going to be a to the n plus 1 x to the n, right? Because I have an n here and just a regular 1 here, so that's n plus 1. And then this is plus 2a0. Oh, I see. And then I'm going to pop out another one to get this one to combine. So I'm going to say this is the same thing as plus summation n equals 2 to infinity 2. And this is going to be an n plus 1 x to the n. And then this is going to be plus 2 a sub 1 times 2 x. So 4a1x plus 2a0. And then we can combine it with this. Oh, interesting. Wait. This is going to be... x to the n minus 2. And then this is going to be plus 2 n plus 1 x to the n. Need to relabel the sum as well. So we can compare coefficients of x. Yeah. How do I think I'd do this? I think I say like n is equal to like, there you go, that's what I wanted to say. Yes. N is equal to m plus 2. Yes, or m is equal to n minus 2. Okay, great. So now, instead of going from n equals 2 to infinity, it's going to go from m equals 0 to infinity. And then this becomes a sub m plus 2. And then this becomes m plus 2, m plus 1, x to the m, plus 2, n plus 1. Now this is like n plus 3. X to the n plus 2? Oh, I don't really feel like that helped me. Oh, wait. I think I see what you want to do. Sorry. Yeah. You want me to not substitute these. I got you. Yes. I leave this. And then I say this is plus the sum from n equals 2 to infinity. And then this is 2 n plus 1 x to the n. And this is plus 4a1x plus 2a0. And then I think from here, I write out the first two terms, right? Is that what we're going to do? So this is the same thing as A2, 2 times 1, x to the 0, plus A3, 3 times 2, x to the 1, plus the summation m equals 0 to infinity a m plus 2. Oh, this is not 0 anymore, right? This is from 2 now. Oh, okay. Got you. And then this is now m plus 2. M plus 1, x to the m, plus all this. Okay. And now I can just combine these two, right? Because they're basically indexed to the same thing, right? Is that what I want to do? Do I want to like recombine these two now? Okay, cool. So now I'm going to leave it as n again. So I'm going to say n is equal to 2 to infinity a n plus 2. I'm going to say n plus 2, n plus 1, x to the n plus 2 n plus 2, x to the n. Oh, this is a mess. And then this is 2a2 plus 6a3x. What do they want? Sorry, by the way. Oh, the first 3 non-zero terms. Wait. And the recurrence relation. Dang. Okay. So I see 2a2 plus 2, so 2 a0 plus a2 times x to the 0 plus 2, and then this is going to be 2a1 plus 3a3 x to the 1. Oh, and wait, whoa. We dropped something here. We dropped something. There should be an a sub n here as well. A sub n. I think I can pull the n plus 1 out. So wait, n plus 1. Then it's 2a sub n plus n plus 2. A sub n plus 2. And this is all times x to the n. Okay. Is this the recurrence relationship? I see something, right? A0, A2, A1, A3, an plus 2. And then they're like coefficient, and there's this n plus 1 out front here. I wonder if I want to put the 2 there and like do that divided by 2. I think that's what I want to do, actually. I think I see this. I think I want this to be n plus 1. This is all over 2. I want this 2 to come out. And then I want this 2 to come, this n plus 1 to come in. Yeah, there we go. That looks better. Now that kind of looks like what I have here. Okay. And then... yeah. I don't really know where to go further from this. Okay, so we know that a sub n... Okay. A sub n plus 2... Oh, because all this has to equal to 0. Oh, yes. Oh. I think I see what's going on here. Oh, okay. Yes, okay. So, a sub n plus 2... So, like, yeah, okay. This thing has to equal 0. So, one sec. N plus 1, a sub n, plus n plus 2, n plus 1, all over 2. A sub n plus 2 has to equal to 0. So, cancel. Oh, very cool. So, a sub n is equal to negative a sub n plus 2 times n plus 2 all over 2. So, okay, cool. So, a sub n plus 2 is equal to negative 2 a sub n over n plus 2. Aha! Oh, that's cool. Yeah, because you need all of these terms eventually to go away. Okay. So this is the recurrence relation? Okay, very cool. So you find the first few coefficients and generate some higher ones. Yeah. What, do I just like set A0 equal to something? And A1 equal to something? Like equal to whatever? Oh, okay, cool. All right, actually, I gotta go run to go teach another student. This is a cool question, though, HHH. Wow, very, very lengthy. Thank you for hanging around with this one. I forgot it. The whole point of this was we were setting it equal to 0. This is one of these things where, like, if you start getting so lost in all the math that's happening, it really helps to pop your head out and take a little, like, view the big picture and be like, wait a minute, what are we trying to do? We're trying to figure out equals 0. Your finals next Monday? Okay. Well, this is kind of a cool question. Do you understand the process of how we did it, HHH? Do you see how we did this? Basically, you write out what the basic series is, do derivative, do another derivative, and then there's a lot of fancy sigma work you got to do with. So you got to like match coefficients, and then you got to match powers, and then you get to this, which is, yeah, this is super cool. And then whatever, write out some terms. Okay, cool. Good question. All right, and with that, let's close out the stream. Thank you, everyone, for coming to Actual Education Office Hours today. Had a really fun time working with you guys. Appreciate all the questions. Lots of fun stuff. Our next stream will be tomorrow. That's going to be at 4 o'clock Pacific, 5 p.m. Mountain, 6 p.m. Central, 7 p.m. Eastern. Come on by. We'll help you out with whatever math or science stuff you need to learn. Let's go raid somebody. Thank you, Shantrix. Appreciate that. I saw your message. I'll get to it. Sorry, I'm just... For people wondering where I am in Discord, I'm in the middle of grading for my UCLA class, so I apologize if it's going to take me a couple days to get back. Yeah. No one really streams on Mondays. Like, what? Excuse me? Is paleontologizing doing something? Oh, his camera's, like, off. Who else is doing something? Teaching together. Oh, I don't really see. Survivorship bias and Sam Demick. Whatever. Let's go see Walking Stick. She's cool. She's kind of a fun person. Go say hi to Walking Stick. She's doing something with spider ecology in the United States and books by the covered internet bodies. Nice. Okay. All right. Enjoy the rest of your Monday. We will see you guys on Tuesday. Peace.
Let's drop the curtain, let's minimize, and let's go to Google Drive to see if anybody left me a topic. And if you're ever curious where I get my topics from, I get them from lots and lots and lots of places.